Hi everyone. Today we're going to work on finding inverses of functions. Okay, so we have talked about adding, subtracting, multiplying, dividing functions, and we did talk about composition in last week. So we want to use a whole bunch of those things today to talk about inverses. So we're going to do a quick review. And this is the list I came up with of stuff about functions. So remember that all our x values are different, and we usually like to think of it as passing the vertical line test. So we had a whole bunch of notation. We had f of x, we talked about g of x, we talked about h of x. And if you remember, like when we first did functions, like probably in Algebra 1, we talked about representing things in order pairs, tables, mappings. Those are the things with the circles and the arrows, graphs and equations. So we're going to take inverses of relations / functions today, and basic premise is that you're going to switch x and y. So an inverse is when we interchange x and y. Okay, so what that means is that we're basically flipping the letters so that x is now y and y is now x. So what exactly does that mean? Well, that means that our domain in the original function is now going to become the range of the inverse. And that the range of the original function is now going to become the domain of the inverse. So they change positions. Okay, so we're still going to use the idea that functions and all the x guys are different, but now we're going to change x and y. Why do we care about that? Because certain things and properties happen when a function has an inverse. All functions are going to have inverses. The question is, will that inverse be a function? So how do we know that? Okay, so let's talk about let's say this as determine if the inverse is a function, because not all inverses are functions. Because we're going to start with a function. So the question is just because it's a function, does that mean its inverse is a function? The answer is no. All right, so there's two ways. First way, does the inverse pass the vertical line test? Okay, you graph the original, you graph the inverse, and then you say, hey, does this pass the vertical line test? Second way, okay, we're going to introduce something new called the horizontal line test. So the question is does the original pass the horizontal line test? So does the original function Okay, now what exactly do I mean by that? It is the same rules as the vertical line test. We're going to draw a vertical line, horizontal line through the original function. If it hits it once, it's a function. If it hits it more than once, the inverse is not a function. For example, okay, here we have a quadratic. Okay, U-shaped graph. There we are. All right, so the original passes the vertical line test. If we draw a horizontal line through that function, it hits the function twice. So that means that the inverse is not a function. Okay, so if the original does not pass the horizontal line test, that means the inverse is not a function. Or you can graph the inverse and see if it passes the vertical line test. Okay, now we have notation, just like we did for inverses. Let me get a room here. Okay, so notation is going to be f with this little -1 x. Now that does not mean 1 over f of x. Okay, we're in function world, not exponent land. Okay, so in functions, that little -1 means this is the inverse. It does not mean put me 1 over, okay? All right, so let's start out simple, okay? Let's find the inverse of some ordered pairs, which we would do for the same if it was a table or if it was a mapping, okay? So all we're going to do is we're going to find, let's start with just finding domain and range, okay, just to practice. So the domain of this function is 1, 3, 7, and 11. And our range is 1, 5, 9, and 13. Okay. Now, according to what we said earlier about inverses, we're interchanging x and y. So the x is now the y and the y is now the x. So we're going to switch these ordered pairs around. Call it f inverse. We'll see if it is. Okay, let's see. Did it have a name? Yep, f of x. So f inverse of x. We'll be interchanging x and y. So the first one doesn't change because it's 1 and 1. But the second one's going to be 5, 3, 9, 7, 13, comma, 11. Okay, notice that the domain became the range and the range became the domain. Okay, it just so happens that this particular function is inverse is also a function. Okay, so all we're doing is switching the x and y's. That's all we're doing. Okay, now as we work through this, we'll take a look at what the graphs look like and so on and so forth. But for now, just think of it as, okay, I'm going to take the x and y's and they're going to change positions. Okay, so let's talk about equations. Okay, there's a 4-step process. This is it's not too bad. Okay, so the first step is to make it y equals. So anytime you're going to be given f of x, if f of x is there, you're going to make it y equals, because you can't interchange x and y if it says f of x. Okay, so we have to make it y equals. Keeping in mind that f of x and y are the same thing. One just says, hey, this is a function. The other one says, hey, it could be a function. It's a relation. So it's just notation. So our first step is to replace f of x with y. So we're going to just make this y equals the square root of 3x minus 2. Okay. Second step, we're going to switch x and y. Now, the easiest way I can tell you to do this is all you're going to do is switch the letters, because that's going to make the most sense. Okay, so we're going to switch the letters. So instead of making this y equals square root of 3x plus 2, minus 2, it's going to be x equals square root of 3y minus 2. Okay, so all we did was switch our letters. Our third step is probably the hardest part, which would be solve for y. Okay, so we're going to take this guy and we're going to solve for y. Now this is where we took place when we did the other day when we solved radical equations. We got to get rid of the radical, so we're going to need to square both sides to get rid of it, because I got to solve. Okay, so I'm going to square both sides of the equation. So we're going to get x squared equals 3y minus 2. Okay, solve for y. Add the 2. Okay, you have a couple of choices. You can divide by 3, you can multiply by 1/3. I'm going to leave it as x squared plus 2, whole thing divided by 3 is equal to y. Okay, and then our last step, we're going to replace y with our notation f inverse of x. Now, I'm only going to do this if the inverse is a function. Only if the inverse is a function. Okay, now, sorry about that. Okay, now, in this particular problem, it's a quadratic. And quadratics are always functions. Remember, we talked about that earlier. So yes, this is a function. So I'm going to go f inverse of x is equal to x squared plus 2 all over 3. All right? Now, if I didn't know that, I could graph it on Desmos. I could come up here, graph this on Desmos, and see if it passes the horizontal line test. Or I can graph the inverse and see if it is a function. Okay. All right, so let's take a look at a couple of these using this process. Let's start out with f of x is equal to 4x minus 8. Now, keep in mind that's a linear and all lines are functions. Okay, so the original is a function. And if you remember the line, does a line pass a horizontal line test? How many times does a horizontal line hit that graph? It would be once. So it looks like the inverse is going to be a function. All right, so let's make this y equals. Switch the letters. Solve for y. Okay, so again, there's a couple of ways you can write this. You can write this as 1/4 x plus 2 if you choose to do so. Okay, that is a function. It's a line. So yes, it is a function. So we're going to write it as f inverse of x equals. Okay. All right, let's try this one. All right, so we're going to start out with making it y equals. We're going to switch our letters. Okay, notice I switched the letters. So x was squared, so now y is squared. Okay, all I did was switch the letters. Solve for y. Okay, now this is y squared. I have to unsquare because I'm trying to get y by itself, which means we're going to square root both sides. Okay. Now remember, when you physically take a square root, there are two solutions, plus and minus. Now, if you remember, plus and minus means that this is not going to be a function. So my answer is just y equals plus or minus the square root of x plus 2. I can't use my f of x notation because this is not a function. Okay, let's try one more. Okay, and again, this looks like it's linear. X over 2, there's no squared or anything, so replace y with, okay. All right, we're going to switch our letters. Okay, we're going to solve for y. I'm going to multiply both sides by 2. All right, y equals 2x is definitely linear, which means it is a function. So I can use my function notation. All right, pause the video, try the other 3 in the other column and see how you did. We'll be back in a moment and you can check your work. All right, so let's take a look at our solutions here. Okay, so the first one in 2, I got x squared over 3. That is a function. Okay, I get, now this one got really weird because I had to divide by -1 first, then switch our letters, or switch my letters, then divide by -1. I ended up with plus or minus the square root of negative x. That's definitely not a function. And in the last one, not a function because I had it square root both sides. And again, when we physically square root something, we get plus and minus, so it automatically makes it not a function. All right, so let's talk about a relationship between the function and its inverse. So let's find the inverse of x squared minus 1. So we get y equals x squared minus 1. Switch our letters. Add the 1. Square root both sides. So we're going to get plus or minus the square root of x plus 1 is equal to y. All right, so we can graph this in Desmos, or you can do it by hand. If you remember, that's just a transformation of 1 unit down. Okay, so this is the original. Okay, so plus and minus, or you can just switch your letter. Best way to do this, I'm sorry, is to switch the order pairs. So instead of being at 0, 1, it would be at 1, 0. Instead of being at 1, 0, it would be at 0 over 1 up 0. It would be over 0 down 1. Instead of being at over -1 up 0. Oop, that last one should be over here. Over 0 up 1. No. I have it going in the wrong direction. Oh, that's because my original point was wrong. It should be here. I was at 1, not -1. Okay, so over -1 down 0 is over 0 down -1. Over, let's do this one. Over 2 up 3 should be over 3 up 2. Over -2 up 3 would be over over 3 down -2. Okay, so you can see that the purple one, which is our plus or minus, is not a function. Okay, but you also can notice that these graphs are symmetrical about the line y equals x. Is the line of symmetry. All inverses and the original and the inverse will always be symmetrical along that line. So in other words, if I take that line and I fold it, every point would line up with each other. There would be a match. Okay, we're going to investigate this a little bit more, but keep that in mind as we work through this. Now, our last thing that we're going to look at is how do we prove that two things are inverses? And I have these two equations, and I want to know, are they inverses of each other? Well, we're going to have to do composition. That's the only way to prove inverses. So to prove inverses, you have to do composition. Okay, which means that you need to do f composed of g of x, and my answer has to be x. And then you also have to go the other way. Okay, so when you're proving, you have to compose both ways and make sure your answer is x. If the answer is not x, then they're not inverses of each other. That's the only way to prove it. Okay? All right, so let's take a look at this one. So I have f of x is equal to 2x plus 1, and g of x is equal to x minus 1 over 2. So we're going to do f composed of g. So that means I'm going to go take g. I'm going to put it in for x, replace the letter in the problem. So 2 times the quantity x minus 1 all over 2, then plus 1. All right, so if we do the math, these 2's are going to cancel each other out, and we're going to get x minus 1 plus 1. Well, that's just x. Awesome. So it looks like these guys are inverses of each other. But I'm not done because I have to do it the other way. I have to do g composed of f. All right, let me move this over here. I ran out of room. Okay, so we have to do g composed of f. Okay, so that means I'm going to take f now, and I'm going to take this entire expression, come over here to g, and take out the x and put it in. So we're going to get 2x plus 1 minus 1, then the whole thing divided by 2. All right, so the ones are going to cancel, and we're going to be left with 2x over 2. The x are going to cancel, and we're equal to x. So that looks awesome. Looks like these guys, because our answers are both x, are inverses. Okay, pause the video. You can try this last one on your own. All right, let's see if you got the right answer. I got they were inverses of each other, because when I switched or did the composition, I got X both times. All right, have a great rest of your day. Remember, staying in means that we're going to stay safe, and I'll talk to you soon.